Alright, so in this video, I will show you how I used bash script to automate common operations that are useful for online coding contests. We will be looking at how these small scripts can be used in various scenarios to help achieve efficient use of the contest time and thus lead to better results. So in my main contest directory here, I have one subdirectory called control. Here we have the bash scripts and the test case generators. So if I go ahead and open these, we have these files here. I can also see the directory here in my WSL terminal here and just ls. So let's go through the contents of this subdirectory. So here is the check script, which I will be using for checking my solutions, essentially. The init script, which is for initializing the directory. This is a template for test generation, okay? It's in C++, of course. This is to delete a particular test, which is faulty. This is to save a test which we manually created. This is to generate a set of tests. And this is a template, the template for our main solution file, okay? Now, initially, when you start the contest, you will need to actually run this init script, okay? So if you run it without any arguments here, okay, let's just go ahead and run it. You will see that you get 6 distinct directories for 6 distinct problems. And you may ask, why are you using individual directories for every single problem? And the answer is that we don't want to mix things up. We don't want to mix solutions and test cases during a code test, because this will create confusion. If this has never happened to you, then you're just either extremely able to remember which file is which, or you're very lucky, because in my case, this thing happened a lot of times, okay? So finally, I got sick of it, and I created this bash script that makes every problem distinct from one another, right? So now, after running this init script, you might ask, hey, how can I create one directory for a problem that has a different name? And I got you covered with this one. Again, you can just run the same command, but this time just give a name. So let's say special. Let's say the name of the problem is called special, okay? And you just hit enter here, and you just have a directory for that problem created as well. So what do we have in one such problem directory? So let's open problem E, okay? Let's just cd here as well. Okay, and let's ls. Okay, let's look at the contents here. So output is a directory used for storing outputs. Okay, it's initially empty. Tests is for the inputs, okay? Then, so similarly, it stores the inputs, which have the same indexing as the outputs. So respective inputs and output pairs will have the same name, essentially. And the only difference will be the extension. So these tests here will end up with .in, and the outputs will end up with .out extensions, okay? So let's move on to the next directory, which is WA, which stands for wrong answer. So this isolates the test which we failed when we were checking our main solution. The check script, the delete test script, the generate script, and the save test script are exactly the same as in the control directory, and do the same thing that I explained before. So here we have the main solution. So the main solution, we have the name of the problem, .cpp. We also have a naive solution, which we implement in the case that we can implement such a solution that we know that it might take a lot of time to execute. So we're not going to submit it and thus get a time limit, but we will use it to check the correctness of our main solution, right? And then these two files here, the input and the output, are just empty text files here, which we will use to manually create inputs and output pairs. And then the testgen.cpp file here is just the file that we might use if we want to create a test case generator. So let's go ahead and look into how we can actually manually create test cases. So we can do everything, all of the things that I'm going to show you just by using the terminal here, okay? So you're not going to have to worry about using your mouse. So here, we're just going to say beam. And let's say we are going to set the input first, of course. Oh, and by the way, let's just define a problem here, okay? So let's say that the problem given is given 3 integers, find out which of the 3 is the greatest, right? So you just have to output the greatest, essentially. So let's just create a test case here. So vim input.txt, and let's just say that the input is 33, 22, 11, okay? And let's just save this. And let's create the output here. So the output essentially is going to be 33, since it was the greatest one. Okay. And now let's implement our solutions real fast. So if you're going to use an ID, you can just simply double click on the file here and open it. So I'm using Sublime. You can also use Vim to implement your solutions, but in this case, I'm just using Sublime to make it faster. So here I'm just going to have 3 integers. Okay, and just outputting the max of the 3. So simply here, I just type this, and let's say we need an endline and the ending as well, okay? So here we have this, and checking again the input here, okay? And the output, okay? Now, having these input and output files having content inside of them, we can just go now ahead and use the saved test script. This is the first script that we're going to use. So bash save test.sh and just simply hit enter, and this gives you saved as an indication that it saved these. And now if you open the test directory and the output directory, the files will be located there. And also this script, the save test script, clears these input and output files so that you don't have to clean it yourself. So this automates a lot of operations that you might and commands actually if you are just using terminal that you would have to do by yourselves. Now, what happens in the case that we have implemented a naive solution as well? So let's copy the main solution. Let's say that the naive solution is exactly the same in this case. Okay, and let's compile that. Okay, now we compiled it. And now that we have compiled the naive solution, let's say that we only are able to manually create an input, but we don't really have the time to actually go ahead and ourselves generate the output. Okay, so the answer here is obviously 22, but let's say that it will take us time to calculate this answer by ourselves. And that's where we're going to use the naive solution here instead. So the output file is empty here. So if I go ahead and run the save test script, it will see that the output is empty and actually use the naive script to generate that output. Okay, so it even says it to you that I used the naive version to create the output. Okay, if it's empty and you don't have a naive solution, it's just gonna tell you that it cannot save an empty output essentially. Okay, now moving on, let's look at the generate script here. So the generate script, so let's go ahead and try running it right now as we have it. So as you can see, it gives you the message, you need to compile both the testgen and naive e files. So for problems that allow for test case generation, that is, it's easy to generate the test cases by yourselves, by all means, go ahead and use this generate script, okay? And actually implement a test case generator. But if if a certain problem requires a lot of time for you to actually generate a legit test case generator, then I suggest that you go ahead and manually create test cases, as I did with using the safe test script. Okay, so let's go to the case that we can actually use the test case generator. So here I have multiple, this is just a template, of course, but I have multiple functions that help me with getting random data, okay? From integers to strings to characters, okay? And here you have the delegation that you just have to see out your test case here. So in my case, I'm just gonna see out a random integer, and let's just separate this with spaces. So let's just duplicate this 2 times. So 3 integers will be printed actually, and the last one will have an endline at the ending. And let's go ahead and compile this. So G++ testgen to testgen. You also have to keep the same name here for this to work. So apart from the main solution, for the other two programs, which is the naive solution and the testgen, you just have to give exactly the name that they have without the extension here. Okay, you just have to remove this extension and just hit enter. So now that we have a test generation script as well, we can go ahead and use generate. And before I hit enter here, let's just look at our directories. So the test directory has only 2 files. The outputs directory has also 2 files, which are the ones that we created with the safe test script. So now if I run bash generate.sh, this will use the naive solution and the test case generator to create 10 test cases, 10 different test cases, okay? Because I'm using a different seed every time. So if I hit this and I go to the test directory and the outputs directory, you can see that now I have 12 tests to account for. Now, what if I want to have a specific number of tests generated? I can simply just give a number as an argument here. So if I say 5, that will create 5 more tests. Okay, so we had 12 plus 5, 17 more tests. Okay, now that we have generated our tests, we can go ahead and check our solution. So if I type down bash check, yeah, here we have the indication that we have given a wrong. Yeah, we have not compiled. Yeah, we have not even compiled the main file. Yeah, I didn't compile the main file. So you get the indication here that you haven't done it. So you get it's pretty verbose here. So you just say G++. The name of the problem is e.cpp, and I'm not gonna give the name because I need the default name to be used. Okay. And now I run bash check, and as you can see, we pass. Okay. So let's try and modify our program to actually be wrong, so that we can see that we identify that our program is wrong. So let's say that instead of typing A here, I typed B. So I only test. Actually, let's say instead of B here, I typed A. So we only check the first number and the third number, okay, that we are given. So if I now go ahead and compile this and run the check, and we get the indication that we have failed on test 3, check the wrong answer directory. So if we go in that directory right now, you will see that we have isolated the test which were failing, okay? So here is the initial, how the input is. This is how the correct output is. This is your answer here, okay? And you also get the difference between the 2 files, okay? So now let's go ahead and test deleting a test, okay? So how to delete a particular test is you go ahead and you say bash delete_test.sh, and then you give the number of the test. So let's say we want to delete this test that we are failing, for example, okay? So if I go ahead and delete it, you will see that it will be missing from the list here. If I ls here as well, you can see that we have no test with number 3, indexed with number 3. So now we can go ahead and run a check again, and let's see if we're gonna fail in some other test now. Yeah, so now we failed on test 7, okay? So that's another test that our main solution fails. And again, it is isolated by itself. So it's just that individual test that we can focus on and find where the mistake was, okay? So those are pretty much the scripts that I have used. We can finally now wrap up this video. And so if we go on and look at the scripts, actually, they are essentially using simple if statements and for loops. It's not like anything very, let me just expand this. It's not something really fancy here. It's just a simple bash script with if and for statements, okay? Now, this contest directory is actually uploaded to my GitHub repository, for which you can find the link in the description below. I highly recommend that you guys either create your own bash scripts to mold them into your own needs and preferences, or you can modify these ones and learn how to use them. If you found this video helpful, consider giving it a like and subscribe to the channel. Thanks for watching.